Welcome. This is the part 2 of the video for geometric sequence for IBDP. So we are going in the part 1 to 20 questions. Now in part 2, 21 to 30. So the annual fees of a school for 2000, 2001 and 2002 are given and they follow geometric progression. So this is going to be U1, U2 and U3. Find the common ratio. So the common ratio is going to be U2 upon U1, which is 8320 divided by 8000, which is going to be 1.04. The fees continues to increase in the same ratio. Fees paid in the 2006. You can see that if it is 2, it is going to be U3. If it is 2001, it is going to be U2. So 1 extra. So if at all it is 2006, it's going to be U7, which is U1 times r to the power of 6, which is 8000 times 1.04 whole to the power of 6, which gives me 10,122.55 US dollars. Now the total fees paid in 8 years. So I'm going to find it out S8. It's a geometric sequence. So therefore I'm going to use that formula U1 times r to the power of 8 minus 1 upon r minus 1, which is going to be 73,713.81. Question number 22. Anne and John. So this is Anne and this is John. Both swim the first length in 2 minutes. So U1 is going to be 2. U1 is going to be 2. John takes 6 seconds more than that. So, and 6 seconds more. So it is arithmetic progression. Whereas Anne takes 1.5 times she took to swim the previous one. So this is geometric progression. In her case, in Anne's case, what is that? R is going to be 1.05. In his case, it is 6 seconds. 6 divided by 60. Common difference is 0.1 minutes because everything is minutes. Now, find the John takes to swim the third length. So he's asking us to find it out U3. U3 is nothing but what? U1 plus 2D. So nothing but what? 2 plus 2 times of 0.1, which is going to be 2.2 minutes. Next, in this case, show that Anne takes 2.205 minutes to swim the third length. So U3, which is U1 times r to the power of 2. So 2 times 1.05 whole to the power of 2. Simplify that, you get 2.205. Part B, find the time taken for Anne to swim a total length of 10. So, Anne. So total length of Anne, Sn, equals to n upon 2, 2u1 plus n minus 1 times d. So 10 upon 2, 2 times u1, u1 is 2, plus n minus 1 is 9 times 0.1. This is for Anne. So which is 5 times 4 plus 0.9. So 5 times 4.9, which is 524.5 minutes. Next, find the time taken for John to swim a total length. So for John, again Sn formula, U1 times r to the power of n minus 1 divided by r minus 1. Simplify that, 25.2 minutes. Question number 23. The tuition fees of first 3 years are given. Find the common ratio. It is a geometric sequence, common ratio. So common ratio is nothing but what? This is U1, this is U2 and U3. U2 upon U1, which is 2500 divided by 2000. It's going to be 1.25. If the fees continues to rise at the same rate, the total cost of the tuition fees after the first 6 years. So I have to find it out S6. S6 equals to 2000 times r to the power of 6 minus 1 upon r minus 1, which is going to be 22517.57813. But is asking to the nearest dollar. So 22518. See carefully for the answer. Question number 24. The population of the Bongar is growing each year. At the end of 1996, the population was 40,000. 1998, it was 44,100. So, assuming that this is annual figures are in geometric progression, what was that in 1997? 1996, 1997, 1998. So this was 40,000 and we don't know it was X, and this was 44,100. Now they follow which sequence? Geometric sequence. So this is U1, U2, U3. So U1 upon U2 upon U1 should be equals to U3 upon U2. So from here I get X square equals to 44,100 times 40,000. So take the square root on both sides. You should be getting the value of X as 42,000. Calculate the population of Bongar at the end of what it says 1992. He's asking us to calculate the end of 1992. So it was 4 years before 1992. So when I do that one, it's going to be 96, 95, 94, 93, 92. So 1 year is over here, second year is over here, third year is over here, and the fourth year over here. So after 4 years, so 4 years before. So now we know that this one was at over here was 40,000. At 96 it was 40,000. So 4 years before. You're going backwards. So 40,000 divided by 1.05 whole to the power of 4. If at all you are going forward, you should be multiplying. Now you are going backwards, so you should be dividing it out. So 32,908. Question number 25. Portable telephones are first sold in the country Selimania in 1990. During 1990, number of units sold was U1 is 160. In 1990, the number of sold is 240. U2 is 240. And in 1992, it was 360. 1993, it was noted that the annual sales formed a geometric sequence. The first term is the 160, second and third terms are given. What is the common ratio? Common ratio, what's going to be the formula? U2 upon U1, which is 240 divided by 160, which is 3 upon 2, which is 1.5. Assume that this trend in sales continues. How many units will be sold in 2002? So which will be 2002? 2002 will be the 13th year. Remember that 2002 will be the 13th year. Why is it so? Because this was 1990, 1991, 1992. So from here, there are 12 years. So this is going to be my 13th year. So therefore, I am going to find it out U13. So U1 times R to the power of n minus 1, which is going to be 20,759. In what year does the number of units sold first exceed 5,000? So 5,000 equals to 160 times 1.5 whole to the power of n minus 1. Use the calculator, you will be getting it out 9.49. So it's going to be 10th year. 10th year means 1999. Don't forget to write the year. Between 1990 and 1992, the total number of units sold is 760. What is the total number of units sold between 1990 and 2002? So it's going to be 13 years. We just came to know that it is 13 years. So therefore, I am going to find it out as 13. So U1 times R to the power of n minus 1 upon R minus 1, which is 61,958. Part E. During this period, the total population of Sulmania remains approximately 80,000. Use this information to suggest a reason why geometric growth in sales would not continue. So, because the population is nothing but what? 80,000, and we are saying that it is almost all 61,000. So, nearly everyone would have bought a portable telephone. So, there would have been very few people left wanting to buy anyone. So, sales would saturate. So, what am I going to write? Nearly everyone would have bought a portable telephone. So there would be fewer people left wanting 2 by 1. Next, question number 26. Consider the geometric sequence, find the common ratio. So common ratio is just u2 upon u1, 6 divided by -3, which is -2. Find the 15th term. 15th term is u1 times r to the power of 14, which is -3 times -2 to the power of 14, which is 49152. Consider the sequence x minus 3, x plus 1, and 2x plus 8. X equals to 5, the sequence is geometric, so x equals to 5. So what does that becomes now? 2, 6, and 18. In that case, the common ratio is 6 upon 2, which is 3. Find the other value of x for which the sequence is geometric. For the sequence to be geometric, what should I be doing it out? Second term divided by the first term should be equal to third term divided by the second term. Then I do the cross multiplication. X plus 1 whole square equals to 2x plus 8 times x minus 3. So x square plus 2x plus 1 equals to 2x square plus 2x minus 24. This gives me x square equals to 25. X equals to either 5 or -5. But 5 already we have done it out. So therefore the other value is going to be x equals to -5. For this value of x, which is -5, find the first three terms. So plugging it out, you'll be getting -8, -4, -2. What is the common ratio? -4 divided by -8, which is 1 upon 2. Question number 27. Geometric sequence has the first term as 1, 3, 1 as its first term and common ratio 3. Find the sum of the n terms is this much. Find n. So 1 times r to the power of n minus 1 by r minus 1 equals to 29,524. So 3 power n minus 1 upon 2 equals to 29,524. You can use the calculator and get the value of n as 10. State the common ratio for the second geometric sequence. For this, u2 upon u1, which is equal to 1 upon 3. Find the sum of 10 terms. S10. u1, 1 upon 3 whole to the power of 10 minus 1 upon 3 minus 1, which is going to be 1.50. Explain why the sum of first 1000 terms of G2 will have same answer as the sum of 10 terms when corrected to 3 significant figures. So what am I going to do it out is, in this case, 1 upon 3 whole power 10, I'll be using it out, and 1 upon 3 whole power 1000, I'll be using it out. And all these numbers are, in either case, they are divided by 2 upon 3. They are divided by 2 upon 3 in either case, and they will be approximately equal to 0 when corrected to 3 significant figures. Corrected to 3 significant figures. So they make no difference because the values will become zeros. 1 upon 3 whole power 10 and 1 upon 3 whole power 1000 will be approximately equals to 0. Very small number. They become very small. So that's the reason. And they are very small and equal to 0. So therefore their value will not be changing at all in either case. We have -1 and -1. The value will not change. Using the results in part A and C, hence or otherwise calculate the first 10 terms. So we can see that it is going to be the addition of the two terms. The sequence is G1 plus G2. G1 plus G2. This sequence is nothing but what? Geometric sequence 1 plus geometric sequence 2. So their addition also will be 29,524 plus 100.1.50, which is going to be 29,525.5. You can see that this sequence is formed by G1 plus G2. Question number 28. A geometric sequence has 1024 as its first term. So U1 is going to be 1024. Fourth term is 128. So 1024 times r power 3 equals to 128. So r power 3 equals to 128 divided by 1024, which is 1 upon 8. So r equals to cube root of 1 upon 8, which is 1 upon 2. Find the value of the 11th term. So for part B, 11th term is 1024 times 0.5 whole to the power of 10, which is 1. Part C, find the sum of 8 terms. S8, 1024 times 1 minus 1 upon 2 whole power 8 divided by 1 minus 1 upon 2, which is 2040. Then find the number of terms for which the first sum exceeds 2047. So 1024 times 1 upon 2 whole power n minus 1 divided by 1 upon 2 minus 1 is greater than 2047.968. Use the calculator. You should be getting n value as 16. Confirm the result D by finding the appropriate sums. So what am I going to do that? I am going to find it out. We know that it is 16, sum of 16 terms. So I am going to find sum of 15. 1024, 1 upon 2 whole to the power of 15 minus 1 upon 1 upon 2 minus 1. Its value I am going to get 2047.9375. If I try to find S16, 1024, 1 upon 2 whole power 16 minus 1 divided by 1 upon 2 minus 1, which is 2047 minus 0.96875. So therefore we can see that n equals to 16 satisfies. Question number 29. A national lottery is offering prizes in a new competition. The winner may choose one of the following: 1000 for each week for 10 weeks, 250 in first week, 450 in second, 650 in third, increasing 200 each week. So it is arithmetic progression. 10 in first week, 20 in second, 40 in third, doubling in 10 weeks. This is geometric progression. Calculate the amount received in the 10th week if you select option 2 and option 3. Option 2, so in 10 weeks. So what am I going to do it at? S10. 10 upon 2, 2u1. u1 is 250 plus n minus 1. 10 minus 1 is 9 times 200. So it's going to be 5 times 500 plus 1800. So which is, calculate the amount in the 10th week. It is not the total. So we just want it out only the 10th week. So we are not finding it out the total. So therefore what I am going to find it out? I am going to find only u10. u1 plus 9d. So 250 plus 9 times of, it is increasing by 200. So it is going to be 2050. In the second case, in the option 3, u10, it is geometric sequence, u1 times r to the power of 9. 10 times 2 to the power of 9. In that case, 5120. What is the total amount received in the option 2? This one is the total amount. 10 upon 2, 2u1 plus n minus 1 times d, 200. So simplify that, you get 11,500. Which option has the greatest total value? So first, option 1 is 1000 times 10 weeks. So it is going to be 10,000. Option 2, just now we found 11,500. Option 3, it is geometric sequence. So 10 times 2 power 10 minus 1 upon 2 minus 1. It is 10,230. So we can see that option 2 is having the highest amount. Lastly, question number 30. An arithmetic sequence is decided by u1 is given. Calculate the first term of the sequence. So u1 equals to 135 plus 7 times 1, which is 142. Show that the common difference. Find u2, which is 135 plus 7 times 2, which is 149. So common difference is u2 minus u1, which is 149 minus 142, which is 7. Then Sn is the sum of the first n terms. Show that Sn can be written as like this: n upon 2, 2u1 plus n minus 1 times d, which is 7. So which becomes n upon 2 times 277 plus 7n. So what does that becomes? 7n squared by 2 plus 277 n upon 2. Then part D, show that the common ratio, first term and the fourth term. First term is given as 20, fourth term is 60.5. Fourth term is 67.5. Fourth term is U1 times R power 3 equals to 67.5. So 20 times R power 3 equals to 67.5. R power 3 equals to 67.5 by 20. R equals to cube root of that, which gives me 1.5. Then finally, Tn is the sum T7, the first 7 terms. So T7 equals to 20 times 1.5 power 7 minus 1 divided by 1.5 minus 1, which is 643. Smallest value Tn is greater than Sn. Tn is greater than Sn. Tn is 20 times 1.5 power n minus 1 divided by 1.5 minus 1 is greater than 7n square upon 2 plus 277n upon 2. Use the calculator to get the value of n as 10. That's all. See you in the next video. Bye.